Hello, welcome back. Today I'm just going to do a problem for AP Physics 2. It basically involves the potential energy it's going to take to assemble a series of 4 charges into the configuration of a square. So it's going to be 4 charges. I'll just go ahead and place the 4 charges in here in a picture. And each charge will have a positive Q. Each one is identical. So the distance between them, we're just going to call length L. So each length of the sides of the cube is equal length, so it basically makes a perfect cube, 4 charges, each with a plus Q charge. All right, so what I want to know basically is how much energy does this configuration have? See, all of these particles here would like to repel each other and shoot away, but it would take a certain amount of force to kind of hold them in this configuration. If they got infinitely far away, they would have no energy. So as I'm bringing these charges with an external force, bringing them closer, it's going to end up having a positive potential energy, and then that's what I want to calculate today. So I'm going to number them just so we can keep track of them. So this is 1, 2, 3, 4. And so basically what I'm going to have to do is add up the amount of energy it's going to take to assemble 1 and 2 together, and 1 and 3, 1 and 4, and 3 and 4, and 2 and 4. So we'll make a quick list of that. So we're going to assemble 1 and 2, and then 1 and 3, and we'll do 1 and 4. Okay, so bring 1 and 4 together. And then we have to get 3 and 4 together. And what else? We got 2 and 4. And we need to get 2 and 3 together. So that should be all the different combinations. So if you look at this diagram, 1 and 2 are a distance L apart. So I'm going to make a little distance. I'll use a little distance column. So go from 1 to 2 as a distance of L. And then from 1 to 3 is a distance of L. 1 to 4, however, is this distance right here. It's this guy right here. So this becomes square root of 2 times L. So 1 to 4 is the square root of 2 times L. 3 to 4 is an L. 2 to 4 is an L. And then 2 to 3 is this distance right there, which is square root of 2 times L. All right, so you notice that this one right here and this one right here are similar. And then you got these 4, they're all very similar as well. So what we're going to do is we're going to calculate the potential energy to assemble these 2 charges, multiply it by 4. And then these 2, we're simply going to add, basically you're going to put these 2 together and say, well, let's calculate what it would take to put these 2 together and then multiply it by 2. And that'll be our total energy of the whole configuration. So U, electrical, is going to equal 4 times the energy it's going to take to assemble that. Remember, our basic equation today is going to be K Q times Q over the distance between them, and that's not squared. Okay, so it's going to be for the energy. So it's going to be 4 times K times, now Q times Q is simply Q squared over the distance L. Okay, that's just for these 1, 2, 3, 4 different. That's where the 4 comes from. Is 4 times just the assemblage of 1. Then I'm going to add to that 2 times the energy it takes to assemble these guys to bring them in this close and this close. So that's going to be again K. There's Q and Q, so it's Q squared over the distance between them, square root of 2 times L. And we're basically done, but I want to clean it up a little bit. So I'm going to rationalize this one, square root of 2, square root of 2. And so I'm going to copy this down for KQ squared over L plus, and then when I rationalize this, I get the 2 on the bottom and 2 on the top. So that kind of cancels away. So I'm left with square root of 2 KQ squared over L. And I'm almost finished here. Let's just tidy up one more time, pull out everything that's constant, that's the same on both sides, and do the rest. So we'll do KQ squared over L times 4 plus root 2. And there you have it. There's our answer. This is the total energy it would take to assemble those 4 charges into this configuration. Thank you, and I hope that helps.